Hey guys, so I'm just gonna set up these meters, these probes here again. Well, not again, no. This is the new one. Well, not new, just never taken out of the box yet. But I made a video series, just like short clips of me transferring the power back into this input battery. So I started, like this machine, it ran for 3 or 4 days. I'm not sure, I'd have to go look back at my footage, the dates on it, timestamps, to see I think it was 3 days. And it brought the battery from 47.98 to 48.94, I think it was. And this one, when I stopped the motor, the resting voltage was 12.97. When I started, it was 13.13 resting voltages. So, and this has been a couple days of resting here now. When I ended the charge, like I transferred the power back with this light bulb again, like some of my previous videos where I just take the negative from this battery, hook it direct to the negative of this, like what was the input battery on the motor, and then I put the positive with this in series with it. So like the batteries are parallel together, but this is in series on the positive lead, which is like a resistor. And it drove like 110 milliamps for almost the whole time, but it took 8 or 9 hours to transfer it. And I did it through a couple days after work type of thing. But anyway, it's resting. And if you guys want to see that video, I'll post it if you guys want. Just let me know in the comments if you want to watch it or not. I have it, and I'll post it if you want to see it. But I brought this down to 47.98, and now it's resting here at 48 a couple days later. So I'm about to start it up here. I'm going to, I've calibrated this scope. I haven't used it in a really long time, so. And that's not a cheap probe either, it's one of the better ones. So it's 4.96 volts. And it's pretty square. It's a 1 kilohertz. And 5 volts and 1 kilohertz. See down there in the bottom right. So that's what that's at. It seems pretty close. So I'm going to hook that up to the motor, and then I'll put number 1 here on the output and number 2 on the input. Turn these on and I'll get them calibrated. I just took this one out of the box. So there. I've got 3 of them, but I only need 2 for this. So I'll be back here as soon as I get it going. Okay, I've got that hooked up there on the input, or the output of the motor. Right there, positive and negative of the coils. It's the same as if you haven't watched the previous video, I recommend going to watch that one first, because it explains the configuration of this right now. This coil's reversed, like it's fighting the other 3. The probes are zeroed out here on the same settings. These ones are the same, it's just a different wording type of thing, labeling for the settings, but they're the same. I'll zero it out and start the motor now. The top one is the input, which is number 2 right here. You can see the cable comes right here. Let me get these a little straighter so you can see. Here. Number 2. Goes to channel 2. That's the top one. So that top is the input. This one's the output. Same settings. And I'll just do this for reference. Turn this one off. This one over here. So now you can see there's the results of that. I'm not trying to fool anybody. And I'll flip this one, put this one on the input. You can see it there. Probes are just vice versa now. There's the readings though. Let's put them back the way they were. This one must be a newer model because it's a little bit more, like it picks up a little bit more of the static noise, but it's reading the same. Same results, very close. And I had transferred the power over a few days. Actually, it took almost a week to do it. So I had brought this down to 47.98. I should have took a video, but this was resting at 13.13. After it transferred the power, it was at 13.15. After 2 days of resting, it went to 13.13 where I started. And I did it the way I did it before with the light bulb. I'd connect the negatives of these batteries together, and then I put the positives together, but with this in series with the positive, and it pulled 110 milliamps for 8 or 9 hours or so. I have the video of it. If you guys want to watch it, I can post it. It's just the power getting transferred over like 3 days. I think it took me 3 evenings. They weren't all in a row though. But I ended up stopping 47.98 where I started on this one. And it rebounded. It rested again at 48.00. And that one rested at 13.13. But now you can see it's under load again. It's going down a bit. Here's the voltage. The top is the input. Bottom is the output. Frequency is the top one. See here, it's hooked to that bridge rectifier, which is on that coil. Which not powering anything, it's just reading the frequency and the voltage of it. And do some current measurements here on the input and output. So the bottom of this one, pause it. So 31 millivolts is 310 milliamps at 48 volts. So that's the output. Switch it to the input. Measure that. Huh. It's really close to the same. 32. waveform is pretty close to the same shape. And with the energy transfer in that video, there was 3.7 volts, I think, going into the light bulb, and just over something like 1.4 some on the input going back to the battery. So there's like 3 times the power going into the light bulb is what was getting back to the battery, which makes sense with this here, the numbers. So not everything adds up. I wish the meters were from the same batch, though. They'd probably be. Let's just measure with this one. See, put that one on the output too. Just remeasure it here. Yeah, the bottom mode, the furthest part down is 34 millivolts, so it's 340 milliamps. And put it on the input. No. It reads like maybe 10 milliamps more than what this one does. So that's on the output here now. That's pretty close, 310. It's almost exactly the same. .31 millivolts. Yeah, 31, 32. It's the same as the other meter. Oops. This one just picks up a little bit more noise, like you can see it there when it's off. It's a little more sensitive. That one's back on the input. Put this one back on the output again. There you go. Pause them and .32. Yeah, there's 33. Has the motor sped up a bit there. We're just getting into its. I don't know if it sped up. Have to look back. Might have sped up half a hertz or so. It tends to do that though for the first while. It bounces around a bit. But there's the numbers anyway. 2 probes at the same time, and there's the voltages. You can see top and base on there. I'll just pause this one too. Change this. Get a better. Come on, hand tech. That's why it's slow. activate that one. Paused. See 12.8 on the input on the top up there, and 51.2 on the bottom is the output. That'll vary, be like 13.6 on the input. It's kind of just the way it is, and it picks up a bit of noise too, backs like flybacks and shit like that. So there's those numbers again. I didn't do the math for you, but I guess I can do it quickly if you're still here watching. Yeah. I'll just be conservative with these numbers. Go with 30. So that's 300 milliamps. So 48 volts times 0.3, 14.4 watts on the output right now. So go to number 2 again. Yeah, it's the same current. I'll be conservative though. I'll go below anything I see. Let's go at 330. Milliamps at 13.11 volts. 13.11 times 0.33. 4.32 watts going in at the highest parts there. There's a little bit more in this area on the current going in. Well, this isn't very far behind at all. $80 milliamps. Oops, gotta flip it back to channel 1. This is at 70 milliamps. So yeah, you're looking at 80 compared to 70 on these two. So it's definitely more on the output, and the results with the transfer proves it. It's just as efficient as a solid state circuit that I have. So there's your voltage and current measurements, precisely measured. But anyway, a long video, so hope you guys enjoyed. Leave yourselves some comments if you want. Try to answer them all, but sometimes I'm pretty busy. Well, actually, I'm always pretty busy. But thanks for watching, guys.